In the previous chapter, we learned about common configurations used in Java applications. In this chapter, we will explore additional declarable configurations available in producer projects, like Java libraries, that affect the consumers of that library. The Gradle ecosystem often deals with producers and consumers. An example is a math library that produces a jar file that is published to a repository and is used by a calculator app. In the math library build file, the Java library plugin will be applied. This makes it a producer of a jar file that is published to a repository. In the calculator app build file, the application plugin will be applied. This makes it a consumer of jar files produced by Java library projects. In this example, the math library has two dependencies: Apache's Common Math and Google's Guava, which are added with the implementation declaration configuration. When the project is built, it produces a math jar file which is published to a repository. This is consumed by the calculator app by adding it as a dependency with the implementation declarable configuration. In the calculator app, the compile class path and runtime class path resolvable configurations will extend from the implementation configuration, so both will have the math library. The Commons Math and Guava libraries are transitive dependencies in the calculator app. Transitive dependencies can also get added to a resolvable configuration. It is important to understand that there are rules on which transitive dependencies get added to which resolvable configurations. Dependencies declared in the implementation configuration of a producer will be added to the runtime class path configuration of a consumer. They will not be added to the compile class path configuration of a consumer. The Java library plugin provides an additional declarable configuration which is not available when applying the application plugin called API. When a dependency is added with this declarable configuration to the producer, it will be added to both the runtime class path and the compile class path configurations of a consumer. When authoring a producer such as a Java library, you will have to look at whether a dependency will be needed in the consumer's compile class path or not. Use the implementation configuration if you want the dependency to be added to the consumer's runtime class path only. Use the API configuration if you want the dependency to be added to the consumer's runtime class path and compile class path.
To better understand the difference between API and implementation, let's go over our example in more detail. We have our two projects, Math and Calc. The Calc project depends on the Math project. The Math library provides a class called complexMathUtil that has a method called fromBigDecimal. This method makes use of classes from both Guava and Apache Commons Math 3. In the Maths build file, Guava and Commons Math 3 have been declared as dependencies from the version catalog. They will be transitive dependencies for the Calc project. Since they are both in the implementation configuration, they will be added only to the Calc's runtime class path, not its compile class path. We can run the dependencies task on Calc and see in the runtime class path the two transitive dependencies available, Commons Math 3 as well as Guava. And in the compile class path, neither of the transitive dependencies are available. If we look at the code in Calc, we can see there's a call to fromBigDecimal. And there's the compilation error. It's not able to find the complex class. In the method fromBigDecimal, the Guava class BigDecimalMath is used internally only. So calc does not need to know about it during compilation, and therefore it does not need Guava in its compile class path. It only needs this at runtime, and therefore in its runtime class path. However, the complex class, provided by commonsmath3, is returned by the method, and then it's referenced in the code and the calc project. So calc will need commonsmath3 in its compile class path so it can properly reference the complex class during compilation. To make commonsmath3 available to both the calc's runtime class path and compile class path configurations, we need to change the configuration of commonsmath3 in the math library from implementation to API. We can publish a new version of the math library. Now when we take a look at the dependencies task in calc, in the runtime class path, we'll still see both the transitive dependencies available. And in the compile class path now, we see commonsmath3 there. If we refresh the IntelliJ configs, the compile error goes away because the complex class is now available during compilation. To recap, when authoring a producer library, if a dependency is needed by consumers during runtime only, use the implementation configuration. If it is needed by the consumer both during compilation and runtime, use the API configuration. Now that you have a good understanding of declarable and resolvable configurations, we can explore ways to fine-tune dependency versions in the next chapter.